In this video, you will learn how to solve different exponential equations as well as natural exponential equations. Okay, let's solve this problem here. Find the solution to 4 to the 4x equals 4 to the x plus 10. Enter a fraction or whole number. So our answer could either be a fraction or whole number, and we just need to solve for the value of x. So when an exponential equation has the same base, which in this case our base is 4, so both sides have the same bases, then the exponents must be equal. And this also applies when the exponents are algebraic equations. So we have 4 to the 4x equals 4 to the x plus 10. Since their bases are equal, then we just have to equate the exponents. So this is just 4x equals x plus 10. And then we group like terms. We subtract x from both sides. This cancels out. Then 4x minus x is 3x equals 10. We divide both sides by 3. Then our x is equal to 10 over 3. Therefore, the value of x here as the solution to this exponential equation is equal to 10 over 3. Alright, let's solve another one here. What value of x makes the equation 5e to the 6x equals 31? So that is 5e to the 6x equals 31. So in this case, we have a natural exponential equation because of e here. So we can just use the natural logarithm to solve this problem, or to solve for x. The first thing we do is we need to divide both sides by 5 to get rid of the 5 on the left side. So we are left with e to the 6x equals 31 over 5. And now we can use the natural logarithm. So this would be ln of e to the 6x equals ln of 31 over 5. And now we can use the properties of natural logarithm. Ln of e to the 6x can be written as 6x times ln of e equals ln of 31 over 5. Then ln of e is just equal to 1. So we'll be left with just 6x equals ln of 31 over 5. And then to solve for x, we divide both sides by 6. Then our x is just equal to ln of 31 over 5 over 6. And if you're going to evaluate this, the exact value of x would be equal to 0.3. So this is our answer here. Alright, let's solve this problem. What value of x makes the equation 4 to the x minus 5 equals 64 to the x plus 2 true? So in this case, the left expression doesn't have the same base as the right expression. So all we have to do is we rewrite 64 here so that our base would be equal to 4. And then once they have the same bases, we can just equate the exponents. So that would be 4 to the x minus 5 equals 64 to the x plus 2. 64 is divisible by 4. Then we can write 64 as 4 cubed. 4 to the power of 3 to the power of x plus 2. Using the law of exponents, we can just multiply 3 to the exponent x plus 2. Now we can equate the exponents of both sides. This would be x minus 5 equals 3 times x plus 2. And this is equal to 3x plus 6. Then we group like terms. Okay, we just have to subtract 3x from both sides. And then we have x minus 3x is negative 2x minus 5 equals 6. Then we add 5 to both sides. And then this would leave us with negative 2x, because this cancels out, equals 6 plus 5 is 11. And then to solve for x, we divide both sides by negative 2, then x is just equal to negative 11 over 2. So this is the value for our x. Okay, let's solve this another problem here. Solve 14 to the x plus 4 equals 6 to the x. Okay, 14 to the x plus 4 equals 6 to the x. Okay, in this case, the two equations on both sides don't have the same basis, but then we cannot reduce 14 and 6 for the two sides to have the same basis, even though both numbers 14 and 6 are divisible by 2. So in this case, we just have to use the natural logarithm and then use the properties of natural logarithm. So we get the ln of 14 to the x plus 4 equals ln of 6 to the x. Okay, by using the natural logarithm property, we can write this as x plus 4 ln of 14 equals x ln of 6. And now we can distribute ln of 14 to the expression in the parenthesis, which is x plus 4. So this is just x ln of 14 plus 4 ln of 14 equals x ln of 6. Now we can group like terms. We can just subtract both sides by x ln of 6. Then we will be left with x ln of 14 minus x ln of 6 plus 4 ln of 14 equals 0. This cancels out. Now we can group this one. We can factor out x from here. So x ln of 14 minus ln of 6 plus 4 ln of 14 equals 0. And then we can subtract from both sides 4 ln of 14. So this would give us x ln of 14 minus ln of 6 equals negative 4 ln of 14. And then we divide both sides by ln of 14 minus ln of 6. This cancels out. And then the value of x would be equal to negative 4 ln of 14 over ln of 14 minus ln of 6. Okay, if we're going to evaluate this using the calculator, this would give us an exact number of approximately, or a number that is approximately equal to negative 12.5 rounded to the nearest tenth. So that is the value for x. Right, let's solve another problem here. Solve 6 to the x plus 3 equals 8 to the x. Again, by looking at the bases here, 6 and 8, we cannot reduce them to make the equations on both sides have the same basis. So again, we can use the natural logarithm here and use the properties of natural logarithm later. So this would be ln of 6 to the x plus 3 equals ln of 8 to the x. Then using the property of natural logarithm, this would be x plus 3 times ln of 6 equals x ln of 8. Then we distribute just like the previous problem. So this is just x ln of 6 plus 3 ln of 6 equals x ln of 8. And then we group like terms. We can subtract x ln of 8 from both sides. Okay, that is 0. Then we have x ln of 6 minus x ln of 8 plus 3 ln of 6 equals 0. Now we can group like terms. We factor out x here, then we have ln of 6 minus ln of 8 plus 3 ln of 6 equals 0. Then we subtract 3 ln of 6 from both sides. Right, this is 0. And then we have x ln of 6 minus ln of 8 equals negative 3 ln of 6. And then we divide both sides by ln of 6 minus ln of 8. Okay, this cancels out. Then this would give us the value of x. So x is just equal to the negative 3 ln of 6 over ln of 6 minus ln of 8. Now getting the exact value of this, we get approximately 18.7 for the value of x. Alright, let's solve another one. Find the solution to 3 to the 8x equals 3 to the x minus 5. So in this case, both sides of the equation have the same base. They are of the same base. So we just have to equate the exponents. So this is 8x equals x minus 5. And then group like terms. We subtract x from both sides. Then 8x minus x is 7x equals negative 5. And then we divide both sides by 7. And this would give us the value of x, which is equal to negative 5 over 7.